Hello everyone. Welcome to day 3 of coding in Java. Today we're going to be going over a couple of concepts and other details that you learned in our previous lesson in day 2. But we're going to take that one step further and learn a little bit more about Java and how we're going to approach these lessons from now on. So today is going to be about something called the robot world. As if you don't know already, we're going to be learning Java from using a application called CarolJRobot. And what CarolJRobot does is that it allows you to fully understand more complex concepts of Java like inheritance and OOP, which will all be covered later in further detail. But the robot world is, say, imagine a world that you live in. Say, for right now, we are living in reality. So the world that we live in is called Earth. We live on the planet Earth. The robot world is a little bit like Earth, but it only exists inside computers. And the only things that exist inside of it are robots. And these robots can be programmed to do certain tasks. And the robot that we're being programmed is something called Carol. We're going to be programming a robot called Carol. It's going to accomplish certain tasks for us. And today we're going to learn about how we can do all of this. So the world of objects. This world, right, called just the world, it consists of objects. And objects are just nouns. They're people, places, they're things. They're just things that exist in reality. Solids, like a cup. A cup is an object. Or me. Myself am a person. I'm a person, so I am an object. Now, in this a system of objects is usually what we want to simulate with a program on a computer. So what that means is that we want to simulate this world. So a system of objects here, it's referring to the world. You have this world, like if you look on the left, it is a traffic system. It simulates traffic flows, traffic jams, and the objects inside of it are cars, pedestrians, traffic lights, stop signs, and of course the road. So now you can see all of these, the cars, pedestrians, all of these are objects because they are nouns. They're places and things. Now, what we're trying to simulate here is this entire setup. We're trying to simulate all the cars to move around according to the traffic lights, maybe stop at the stop sign, pedestrians walking by. And that's how the world works. We create the world, and then our program is meant to simulate it, meaning to make everything move how it's supposed to. And then on the bottom left, you'll have another example, the grocery system. So the point here is to simulate checkout at a grocery store. If you're shopping at a grocery store and then you want to check out and pay at the cashier, you take these items and you go to the cashier. And then what we're trying to simulate is having all the items being checked by the cashier and the money returned. And the objects here is the cashier, the customer, and the groceries. So the basic concept here is that in this world, you have the world of objects, and the world of objects is being simulated by yourself using a program. Now we're going to go over object properties. So you know what objects are. They're the things that go inside a world, and the world is made up of all these objects. So now, how do we differentiate these objects? One way is by their attributes. The attribute of an object is its state, its characteristics, or its properties. So what that means is that an attribute is just the properties or the description of an object. It's how I describe an object. If I have a cup, then the way I would describe it is that the cup could be X meters, not meter, X inches tall or X inches wide. Or I could say that it's white, it's red. I could say what kind of a handle it has. The attributes are just things that describe the object, how it looks like, and what it is. So and a method is the actions or operations that an object can do. So let's say I have a cup. The actions it can do are, say, store water or be placed down. Their actions are just things that a an object is able to accomplish. Like if I am myself an object, my name is Bill, and then if I create an object named Bill, then you know that it's me because the attribute could be person, it could be black hair, it could be Asian. It's just it's just attributes that describe an object. And then my methods could be something like move hand, move head, walk forward, because there are things that I can do. And then messages are when an object tells another object to do something. So what that means is that it's um it's when you tell the object to actually use their method, because the object itself, it only has this information of the method. It only has information to do this thing. In order to actually make it move, in order to actually make it do anything, you have to tell it to do something. Because remember, this is a robot. It's not conscious. It's not conscious. You can't it doesn't know by itself what to do. You have to tell it what to do. So an example here is this bank account. That the attributes of this bank account could be, say, the owner is John Doe. So the owner of this bank account is this person named John Doe. And then maybe the balance of this bank account could be $142.30. And then the kind of bank account it is a checking account. All of these fall under the category of attributes. All of these are attributes of this object, of this bank account. And the methods, such as the things that a bank account can do, are something like deposit and withdraw. You can deposit money in this bank account and you can withdraw money from it. And those are all things that this bank account can do, which makes it a method. And then a message. You can tell the bank account object to deposit or withdraw money. The bank account knows how to deposit and withdraw money, but in order to actually do that, you have to tell it to do that because you yourself are in control of it. In real life, when you have a bank account, the bank account isn't going to deposit and withdraw money for you. You have to go to, like, say, an ATM or the bank, and you have to do that yourself. It's the same concept here. Now we're going to have a review of objects and classes. So objects, and this was covered in last lesson, but objects are instances of a particular class, meaning a class is a collection of these objects. So the classes categorize these objects. So if you were to have, say, a class named people, then or person, then the objects of that class would all be people, like you or me, because we are all people. We would fall under the class person. But an instance is an example or single occurrence of something. So in coding, when we say that an object is like a part of this class, we say that it is an instance of this class. It's a general coding term that I am an instance of class person. And you have the examples here. You have class circle. Each of these circles is different, just like how you and I are different. But each circle is in the end a circle, such as how both you and I are both people in the end. And therefore, they are all instances of class circle. And if you look at the other examples like square and line, these are circles. So therefore, they cannot be part of class square or line because they are ultimately circles. It's the same here with squares. You can see these are different squares, but they are so squares, so they are part of class square. And then you have one line, and that is class line. Now, a little further depth into classes. So classes are descriptions of objects that have the same attributes and methods. So you know that classes are collections of objects that are like similar. They fall under one category, and that category makes the class. But a little further into depth, a class is a basic model for creating objects. So a class describes the attributes and methods that these objects have. So if you were to have class cup, and then the attributes could be width, height, and color, then all the objects that you create using class cup, meaning all the instances of class cup, they have the attributes that you define for class cup, meaning every single one of these cups, they have the attribute of height, width, and color. None of these instances can have any other attribute. any other attribute, meaning they can't have any other description. So they have um they have height, width, and color, but one cup cannot suddenly have owner as well. You can't just add in another attribute. You, and you also can't just take off another attribute. When you define a class, you're defining the attribute that fits every single instance of that class. So you can think of that as a cookie cutter. A class is a cookie cutter, and every instance of that class is a different cookie. Now all these cookies could be different kinds of cookies. Like one could be chocolate chip, and one could be oatmeal. They're made of different kinds. They're made of different materials, so they're different cookies. But in the end, you're using the same cookie cutter to cut them, so they're the same size, if you were to say. So to create objects, we need constructors. So the class is a cookie cutter, and then the cookie cutter cuts objects out of dough to create those objects. But then the person that cuts the objects that actually uses the class is a constructor. The constructor is what takes a class and creates the object while also defining the object's attributes and methods. So you have class cup, and then you're creating a let's say you're creating a white cup that is 5 inches tall and 3 inches wide. So in order to create that, we would use a constructor that tells the computer, I want you to create me a cup that's white and that's 5 inches tall and 3 inches wide. And then it's also part of class cup. And that is how constructor is used, basically. And then after an object is constructed, only then can it use its methods, which is kind of obvious. Unless an object is actually created, it can't actually do anything, right? So you have to create it first using the constructor, and then you can use the methods that it has, because then you're creating it in existence. Now, the robot world. The robot world, as you remember, consists of objects. And these objects are robots, walls, and beepers. So if you look to the left, you have an example of robot world. That's what a robot world actually looks like. So I think explained before, inside a robot world, it consists of objects. And these objects make up the world. And these objects are people, place, and things. They're nouns. So now, more specifically, these objects are robots, walls, and beepers. These are the only things that can exist inside the Kiro program that we're going to be using. In the robot world that we are creating, only robots, walls, and beepers exist. Right. So robots and walls, they're pretty self-explanatory. You know what they are. Robots are the things that we create, and then they go inside the world and they start moving around and do things. And walls are just walls. They prevent the robot from moving past them. And now, what are beepers? So beepers, think of them as coins. They're little collectibles that you can have your robot collect. So beepers, they don't block movement. You can move over them as you want. You can move over them. And a unique function is that you can actually pick them up. You can make robots. You can make your Kiro pick up the beeper. So if you look on the left, that's your example. The robot are these little purple arrows, right? They're the way that they are oriented shows the direction that they're facing. So let's say this one's facing east, north, east, southwest. This one would be facing west. This one's facing north. That's quite simple. And these are the walls. And obviously you can see that these at the bottom, at the left and bottom, you have a basic wall. You can think of this as a graph. Like this is X and this is Y. And then you have your streets, which go left and right, and your avenues, which go up and down. And then if I were to say that a robot is, say, at street 2, avenue 1, you go to street 2, and avenue 1, it would be right here. You're just using X and Y as you learned in math class. Very simple. So then when you first create a robot, the default creation point is at the origin, or 1, 1. And in math class, you know the origin is 0, 0, but in the robot world, the origin is 1, 1. So remember that. It's where the robots are created. Of course, you could also create robots at different places. I could say that this robot will be created at Street 6, Avenue 2, and it will be created right here, and it's also facing east. So then the capabilities of a robot are that they can move forward, they can turn in place, and they can pick up and put down beepers in its beeper bag. And the beeper bag is like a virtual storage location for all the beepers that one robot has. Because every robot has its own beeper bag, and each beeper bag has its own amount of beepers that are stored inside. Now then, what are programs? So when we want a robot to do something, we send a sequence of messages of how to do it. We want the robot to do something, so we tell it exactly what we want it to do. So the robot receives, memorizes, and follows those instructions that you gave it to it, and then those instructions, all of them, are called a program. A program is basically a something that we want the robot to do, or a certain task. We want the robot to do something specific. Like if I want a robot to pick up my cup, I would give all these instructions like move over to table and then like take your hand and grab the cup and then pick it up, all of these, all that, and then that becomes a program. And these instructions, they're written in a special language. And this special language is something called binary. So binary is basically what the computer is reading. It's it's the computer language, and you can think of it as a coding language where you can't actually code in it because it's computer language. Only the computer can understand and read binary and do what it and do and understand that what you wanted to do. So in order to program these instructions, you have to type in a coding language like Java. So the one that we're learning is Java, but of course there are many other languages that you can learn. The one that we're going to be learning is Java, if you haven't noticed already. But these tasks are something that we want a robot to do. For example, like to move somewhere. If you wanted to move from one location to the next, you may have it move like space by space, maybe a turn so that you can move around because it's a grid. And then we can make it pick up a beeper. And then a more complicated task would be something like escape a maze. We can put the robot inside a maze, and then we can make it find the exit and get out. So a situation is an exact description of robot's world. So if you look back on our previous slide, this right here is an example of a situation. It's the exact description of a certain robot world. This is a copy of a robot world where everything is facing like this. So a situation is it tells you where the robots are, what direction they're facing, maybe where the walls are, where the beepers are, how many beepers are in each robot's bag. So it's everything about a single robot world. Now we're going to go over the UrRobot class. So you can pronounce this however you want. UrRobot is really your preference, but the class UrRobot is used to create instances of robots in robot world. So UrRobot is a predefined class, meaning someone already created this class for you. It's got everything inside, it's got all the attributes and methods. Now the only thing you need to do with it is take it and start creating objects with it. Use a constructor and then start creating instances of class UrRobot. So then UrRobot has 5 methods, which are move, turn left, pick beeper, put beeper, and turn off. All these 5 methods are used to make your robot do what you want. You combine these 5 methods to create your program. So first we're going to go over move. What does move do? It's quite obvious. It moves forward 1 block. It ends facing the same direction, and if it moves into a wall, it'll perform something called an error shutoff. What an error shutoff is that it basically shuts the robot off. The robot will say to itself, hey, I can't do that. And there's a wall in front of me, I can't move past that, and therefore I'm going to shut myself off because I have received an instruction that I cannot do. And this is going to be explained further into detail in our next lesson, but for now, just understand that when it performs an error shutoff, then the robot will completely shut itself off. And you have to avoid this because if you have an error shutoff, then your entire program is wasted because after an error shut off, you cannot do anything else. So you want to fix that immediately. So this is an example of a valid move. There's nothing in front of you, so you move forward, and then that's it. But if you're facing a wall, then your robot will stay in the same position, and then it will also perform error shut off, shutting itself off. Now, two more methods. Turn left. A robot basically just turns 90 degrees to the left. So the robot stays on the same corner, and what a corner is that it's the intersection between the street and an avenue. So it's all of these dots right here, these intersections. They're all the places that a robot can move to. So the robot stays on the same corner, and then one thing to know about this is that it cannot perform an error shut off. You can turn left as many times as you want, and it'll never fail because all you're doing is just turning your robot. And then you should notice that your UrRobot class has a turn left method, but where's the turn right method? There is no turn right method. So if you want to turn right, you have to turn left 3 times. And then one of our last methods is pick beeper. So pick beeper makes the robot pick up the beeper on the corner that they are on, and they pick it up and they put it into their beeper bag. So in order to pick up a beeper, they have to be on the same corner that the beeper is on. And when the robot is on this, you might not even see the beeper. So you just have to know that the robot is on that beeper. And then you have to pick it up. And if there's more than one beeper on the corner, because there can be multiple beepers on the same corner, then the robot will only pick up one beeper. If you want to pick up every single beeper on that corner, you need to continue picking all of it up. And one thing to notice is that if you try to pick up a beeper on a corner where there is no beeper, meaning you just go somewhere where there's no beeper and you try to pick it up, the robot will perform an error shut off, just like how if you try to move into a wall. And then our two last methods, put beeper. So the robot takes a beeper out of its beeper bag and then puts it on a corner that it's standing on. But one thing to note again is that if the robot's beeper bag is empty, meaning the robot has no beepers, it hasn't picked up any beepers, then if you try to put a beeper down, well, there's nothing to put down, and then your robot will perform an error shut off again because you cannot do that. And then our final method is just turn off. This method won't be used as much because you're just turning it off, and it doesn't have that much of functional value, but it just turns itself off. Like it's performing error shut off without the error. It's not actually an error you're trying to actually make it do it. Now we're going to go over a review of your robot as well as an extension. So class UrRobot doesn't only have 5 methods, it also has 4 attributes. If you don't remember, a class has attributes and methods. So when you're creating an instance of class UrRobot, you're also creating the attributes for it. You're defining what attributes it has. And the attributes for your class UrRobot are street, avenue, direction, and the number of beepers or num beepers. So the street is the y-axis position, avenue is x-axis, and then direction is north, east, south, or west. It's what direction it's facing. And number beepers is how many beepers it has in its bag. So we're going to use class UrRobot to create an instance of the robot. And then we have a constructor which creates the instance. It gives the robot its name and sets up it in initial situation, meaning you set up in y and x. And then you also give it its attributes, what direction it's facing and the number of beepers it has. And from there, we can program it to move however we want. So an example of this, let's say we want to create a instance of your robot called Alice. So we would write UrRobot Alice equals new UrRobot 62 East 1. What does that mean? So what that means is that UrRobot, right, is that's the class that is defined. So you in this class, right, you have UrRobot. So the first thing that you write when constructing a robot is the name of the class, because the community needs to know what class you're actually using, because there's not just one class in existence, right? You have a lot of classes, so you're going to use UrRobot. So that's the first thing you're going to do. You're going to type out the name of the class you're using, and then you have a space between that, and then you're going to write the name of the object. So in this case, we're creating a robot called Alice. So we write UrRobot Alice, and then we would know that we're creating an object that is of class UrRobot, and then its name is Alice. And then you write equals, you write new because it is a new object, and then the same class again, so new UrRobot, and then you define the parameters here. So then if you don't remember, you the first number is street, the second number is the avenue, the third parameter is the direction, and the final parameter is the number of beepers in its beeper bag. So in order to create this instance of your robot called Alice, sitting at street 6, avenue 2, facing east, and with one beeper in its bag, you'll write this entire statement. And then one thing to note is the semicolon, which is a delimiter. And don't recall if I covered this in our last lesson, but basically what the not on delimiter, I mean, but a semicolon is, it marks the end of a statement. So this tells the computer that this is the end of this statement. So it's a little bit like a period. And to get Alice to actually move, we would write alice.move. So then you're telling the robot called Alice, because that's the name of the robot, and you're making it move. And then these parentheses are here because of the parameters. So you have right here, these are your parameters for your attributes, because the class UrRobot has 4 attributes, but the method move has no attributes. So you would just put an empty parentheses because there's nothing that goes inside of it. And then you would just write the semicolon once again. So basically, we get a robot to execute an action by sending it a message. And we execute a program by carrying out each instruction in that program. So this is an example program. So our task is to initialize Alice, an instance of UrRobot, to start on 2nd Street and 2nd Avenue, and then to transport a beeper from 2nd Street and 4th Avenue to 4th Street and 5th Avenue. And then after putting in the beeper, Alice moves 1 block further north. So that's our task, right? And how do we do that? So this is the example of the code that would actually accomplish that. You don't need to mind this first statement right now because that will be explained in a later lesson. But here you have, let's say we create a class called moveRobot, right? And this class is going to make the robot actually move. So, and then what you want to be paying attention to is right here. This little block of code right here, that's what's actually doing the what we want. So we want to move here, right? This is the initial situation. So you've created a robot at Avenue 2 and Street 2 because that's what it says to do. And it's facing east. And then you want it to pick up this beeper. So you make it move twice, once, twice, pick up the beeper, move again, turn left, move twice again, put the beeper down, and then move 1 more time. And then you have accomplished all these tasks. That's basically it. You're just combining all of these methods, just these 5 methods, and then you're going to accomplish your task. It's very simple. And that was basically what we're going to be diving into first before going on to other more complicated concepts to be learning. That's how we're going to be learning Carol. And then one more thing, I'm going to look at grammar. If you didn't see like what we were doing before, how we were coding it, but I'm sure the constructor and how to write all this code is very confusing. So I'm going to go over this a little bit. So we have main, right? Main is where the computer looks at the method with this name and executes each instruction inside it. So basically, when you're writing code, right, you have all these methods, you're creating all these classes. In order to actually do something, to send messages, right, you have to you have to use something called main. So you have to create a method called in main, and then main is what you're actually doing. It's not main isn't an actual method. It's more a name that tells the computer, oh, this is what I'm actually going to be doing. So all of your methods and other code will go inside this method, and then the computer will execute all the instructions inside main, and that forms your program. So then a new indicates a new object as explained before. So you have your class, you have your variable name, it equals, and then new just tells you that this is a new object. And then the brackets. So you have left and right bracket. Those are called delimiters. They indicate the start and end of a body. So if you look right here at main, these don't look that much like the brackets because they're kind of strange right now, but they're the same thing as this. They just tell you what's the start and end of a certain method. So this is main, right? It's the method that I explained before. This left bracket tells you that this is the start of the code. It tells the computer this I'm starting my code right here. And then the end bracket tells you, oh, this is the end of the code. So all of this is categorized as under main. And you also have the semicolon. It indicates the end of a message. As I told you before, like a period. And an indentation just makes it easier to read the code. So as you can see, main is like a little toward the left, a little more to the left than the rest of its code. And that's because the rest of the code it's like it's a little um it's like etiquette, I guess, coding etiquette to indent because it makes it easier to read your code. And then so then right here you can tell that all the code under main is under main because not only because of this, but it's also indented. We sometimes this is a little hard to see. So if you're looking through all of your code, then you can see that like this piece of code is indented below main. So then you know that it's a part of main, and then you can access and read all of your code easier. And then that marks the end of our little lesson. So thank you all for watching. More material will be covered in our next lesson. And if you haven't already, please check out the my previous lesson, Java Day 2, because it goes over the basic framework of what we're going to be learning. And it's a little broader concept of what happened in this lesson, because this one really went a little bit more into detail. And then in later lessons, we'll actually be starting to code. So yes, thank you for watching, and I hope to see you in a future lesson.